Knowing how to set up a proper Git workflow is critical for coding projects that involve group collaboration. If you follow certain procedures, you can always keep a clean working copy of your project through identifying code issues before they become incorporated into the larger project. At its essence, this workflow attempts to insulate code bases and prevent problems before they happen. This simple demonstration to a Git workflow aims to help give an introductory overview for structuring a group project. I will demonstrate using the fork and pull development model. With this model, anyone can fork an existing repository and push changes to their personal fork. In the example, we are forking the PowerShell gallery from the Microsoft GitHub repository into the Cloud Tag GitHub repository. The PowerShell gallery is used by Microsoft, its partners, and the community to share PowerShell code. By forking it into the Cloud Tags GitHub repository, I can then do a clone to my computer and make modifications to the code. Once I am done, I will demonstrate how to make a pull request to the maintainer of the PowerShell gallery. The PowerShell gallery contains the core code of my project. It is the central working directory that anyone contributing to this project will draw from. The first step, therefore, is to fork the project into my CloudTag GitHub account. To do this, I'll go to Code, the drop-down menu, and I'll copy the HTTPS link. Once I'm done, I'll do a git clone of that repository into my local computer. I can verify that I've cloned the repository, and this is the PowerShell gallery. I'm going to change directory into that gallery and list the files. I want to make sure I'm in the master branch. So I'll run the git branch command. It tells me I'm in the master branch. The master branch contains the functional working code. What if I want to update the project? Where should I make the changes if the master branch can only have clean and functional code? I will create a new branch in order to make and test my changes. To do this, I will use the git checkout command to create a new branch called feature and then navigate to that branch. So git breakout -b, and I'll specify the branch as feature. The command is git. So the command is git breakout, git checkout, that's B to specify that I'm creating a new branch, and I'll call this branch the feature branch. All right, so I've switched into the feature branch. Before making any changes, there is a possibility that someone else might have made changes to the PowerShell gallery or upstream repository. Since it is the repository I forked the project from, I would want to pull in the latest functional code. This means I will have to add a link to that upstream repository from my local computer. To do this, I will use the git remote upstream add command. The upstream here refers to PowerShell, so I'll go to PowerShell. I'll copy the link and paste that here. So if I do git remote -v, I should be able to see the origin. The origin is my own GitHub repository, and upstream is where we forked the project from. The git remote -v command allows me to list the upstream and origin repositories. These are the two destinations or remote repositories I am working with. At this stage, I am ready to begin making changes to the code from my feature branch. The change I want to do is to modify the text in README. So just to have a view of what's written in the README text, I'll do cat README, and I will vim into this file and make some changes. So I can just say Hudson changed and modified the README text. Okay, that's my change. I will save my file, right quit, and if I do git status, I see this file has been modified, the README text has been modified. After the modification, I will now add and commit the files to my local or the Git repository on my computer. The command I use is git add README and git commit. Specify a message, say Hudson modified the Git README text. Every step from this stage onwards ensures that only clean and functional code is incorporated into the project codebase in the upstream repository. The goal is to isolate any potential code conflicts by adding safeguards to ensure the project's code is not harmed by anyone's contribution. Before I add my changes to that repository, I want to make sure my changes do not conflict with anyone else's code. To do this, I will need to pull down from the upstream repository the most recent project files to my local computer. This would allow me to make the most up-to-date comparison. First, I will check out into master. To do git checkout master, clear my screen, and then since I'd already specified the git remote upstream, I can simply do git pull upstream into master. So now that the master branch is up to date, I want to incorporate any changes into my feature branch. In this case, there is no change, but let's assume there is for best practice purposes. I will use the git merge command, but first I will switch back into my feature branch. So I type git checkout, the branch is feature. So we are in feature branch. Then now I will perform the merge from the master branch into my feature branch. So that is Git Merge Master. Okay. At this stage, if there are any conflicts between the code we have modified in the feature branch and the master branch which we have just pulled, we will see them now in the feature branch. Any potential conflicts will be discovered and resolved here in my local machine, in my own feature branch, and away from the main upstream repository. My code is prevented from harming the overall project, and I can fix any problems before they are incorporated into the code base. Fortunately, there are no conflicts after the merge. I will now push my code changes to the origin repository, which is my CloudTag remote repository, from my local computer. So that will be Git Push origin from my feature branch. In the origin repository, which is the CloudTag's personal repository, I will first do a pull request into the repository's master branch from the feature branch, and then later on initiate a pull request to the upstream master branch. To do this, I'll click on compare and pull request. It tells me then I will select my base repository as the CloudTag PowerShell gallery, and the compare branch is the feature branch. I can specify, I can comment on what I did. Say I modified the README text, and then create a pull request. Once it confirms that my branch has no conflicts with the base branch, I can now perform a merge pull request. Confirm the merge, and the pull request is successfully merged and closed. So I can delete. Best practice is to delete the branch after you're done working with it. So now if I go back into my repository, it also tells me this branch, which is my own master branch, is 2 commits ahead of the PowerShell master. The PowerShell master is the remote upstream repository where I forked this project code from. So I'll do a pull request and create a pull request. If I create a pull request, the maintainer of the upstream repository will be notified to review my proposed changes, and if they are necessary, approve the changes and incorporate it into the project code. Since this is just a demonstration, I won't be initiating the pull request, but this is how you would do it in real life. Hopefully, following these steps in the demonstration will help make collaboration easier and less error prone for you.